And the last thing that we're going to deal with property of matter is what's called latent heat. Considerably easier equation than specific heat. Okay, heat, Q, thermal energy, is equal to the mass of the object times its latent heat capacity. Now, notice that there's no change in temperature. When you're dealing with latent heat, you're talking about a phase change. Whether an object is going from a gas to a liquid, gas to a solid, or solid to liquid, solid, on and on and on. So when you talk about using latent heat, you're talking about a phase change. And why there is no change in the temperature, why an object is experiencing the latent heat, the phase changes, is because all the energy that you're pumping in, all that thermal energy that's going into the system, is being converted into potential energy. It's actually increasing your potential energy. If you think about it, when we talked about stability, it's an object is more stable the bigger its potential energy is in the negative. A huge negative potential energy means that the object is pretty stable. So when you talk about solids, they have a huge negative potential energy. When I dump energy in there, I'm starting to fill up those reservoirs. When I've completely filled up the reservoir, the object is now a little less stable, which means that it is no longer as stable as a solid. It transforms itself into a liquid. Okay, so when dealing with phase changes, we think about all that thermal energy going into increasing the potential energy. It's because that potential energy is such a big negative, you're filling it up, filling it up, filling it up to reduce its stability. I mean, obviously, a solid is more stable than a liquid, and a liquid is more stable than a gas. Okay, and a gas is definitely more stable than plasma. But that's kind of what it means. So you're removing that stability, and the way I'm removing that stability is to increase its potential energy. Okay, because we want that potential energy to be negative, and by a huge number. Okay, cool. So that's latent heat. So we've talked about linear expansion. There's a volumetric expansion, but we're not going to concentrate on that. Specific heat capacity, and now latent heat capacity. Okay, cool. Those are the properties of matter that we're going to deal with. Remember, there's also a discussion about monatomic and diatomic gases, but I didn't put them in the properties of matter because I want to kind of separate that, because it is a gas. It's specific to gases. Okay, cool. All right, that is latent heat.